All right, so today we're looking at proving an identity. And there's a few ways of proving identities. The most popular way is going from one side to get one side to the other side. So going from trying to go from this side to the left and trying to get to the right, or beginning with the right and trying to get to the left here. And then that's the most popular way of doing it. Now, the other way of doing it, which we'll go over today, is by trying to get both sides of these expressions to equal each other. Okay, so I want to get to a point where one side looks exactly like the other. All right, so and you can completely do this, by the way, by going from one side to the other. It is a little challenging and it is a good problem to work on, but that's not the focus of today. So let me start with the left hand side. Sine cubed plus cosine cubed theta. And that reminds me of this identity that we have. X cubed plus y cubed equals x plus y times x squared minus xy plus y squared. Now, this might not jog your memory. Most students that I know that are in pre-calc don't remember this formula, and it's a handy formula to have here in terms of for factoring and such. Okay, so it's called the sum of cubes, and yeah, I just know it pretty much because when I tutor, I go over this formula quite a bit, so it's stuck with me. And you also have what we call you have the sum of cubes, which is this one, x cubed plus y cubed, and you have the difference of cubes. Very similar formula, except that there's a minus here and then there's a plus in the middle. Okay, so I'll let you look at that. And by that, let me go ahead and rewrite sine cubed plus cosine cubed as the following. Sine theta plus cosine theta. So sine is like the x, cosine is the y, times sine squared minus sine theta cosine theta plus cosine squared all over 1 minus 2 cosine squared theta. Oops, I'm running out of room here. And then on the other side, we have the secant theta minus sine theta all over tangent theta minus 1. Okay. All right, and looking at that left-hand side, I see that I have sine squared plus cosine squared. So that's going to give me 1. So you get 1 minus sine theta cosine theta over 1 minus 2 cosine squared theta. And theta minus 1. And I'm going to now work with the right-hand side. 1 over cosine theta minus sine theta. So I'm going to use the identities for secant and tangent as reciprocals of sine and cosine. And I'm doing this because the left-hand side is in terms of sines and cosines, so I want to have one or two trig functions that they all have in common. Okay. And I'm just going to write this down. And what I'm going to do with that right-hand side is this. This is what we call a complex fraction. And I'm going to multiply both the numerator and denominator by cosine. And I'll explain why right now. There's a couple ways of simplifying this. This is one. And the way it works is if you go back to the previous step, if you looked at all the fractions involved, all 4 of them, you were to, get a common denominator for them, be cosine. And when you multiply by that common denominator on both the numerator and the denominator, and we're doing it to both the numerator and the denominator here, by the way, so we can get rid of all, to simplify this expression, you get rid of all these fractions that you see here. Even though the one big fraction stays, so I'll explain that in a second. So to distribute cosine on the numerator and the denominator, you would get 1 minus sine cosine, and and then distribute the cosine, you would get sine minus cosine. Okay, and that's what I meant by just one like big fraction. All right. Okay, so this is where we're at, and I'm sorry, I should have been a little more careful writing this. Let me rewrite this. Okay. All right, so now what? Sometimes you got to look at what's given to you and where you're at kind of situation with identities. And notice that you have a 1 minus sine theta cosine theta term on both sides. Now obviously the left hand side has a little more, and what that is kind of calling me to do is to maybe work more with the left hand side, and maybe I could possibly get rid of that sine theta plus cosine theta somehow. Okay, well, here's how we can do it. Now this is a little sneaky, but where you have that 1 minus 2 cosine squared, I'm going to rewrite that as 1 minus cosine squared theta minus cosine squared theta. And the reason I'm doing that is because that one, if I look at this is like saying sine squared theta. And equals and the bottom, sine squared minus cosine squared, that is a difference of squares. X squared minus y squared equals x minus y times x plus y. So you have sine theta plus cosine theta. Cancel right there, and there we go. Both sides equal each other. And that is it. So a lot of people don't like this way because, and what I'm writing here is these double implication arrows, is what we call if and only if statements. And basically we're saying that one relies on the other in so many ways. And this would go all the way to the top here. All right. Yeah, a lot of people don't like this method because it's somewhat messy with both sides of the equation, and you got to write a bunch of stuff. And for some people, it's hard to keep track, to each their own, I guess. I prefer going from one side to the other, but sometimes that's really difficult. I've had, I don't know how many cases where you're trying to get from one side to the other and nothing's working out. So this is for me, this would be my last ditch effort, but if you feel differently, prefer doing this, by all means. All right, thanks for your time.